Hello, my name is Joel George, and this is my Kinetic Sand project. So as you can see, we have everything set up. I've got two containers. This one I put some water in. Got a couple packets of colored sand, cornstarch, of course, and my tablespoon. So we're going to start by putting our sand into our big container. Right. One and two. Okay. Next we're gonna put in 1 tablespoon of cornstarch. Okay, got our tablespoon. And we're just gonna mix all of that together. All right, so we have our cornstarch and our sand mixed up. Next we have our water. I'm gonna add some of our dish soap. Okay, then we're gonna stir that together. So we have our dish soap mixed together with our water and our cornstarch and our sand. The video says to add just a little bit at a time here. Gonna add a little bit more. The video said the trick is to go pretty slow so you don't add too much moisture. Alright, I think we might need to add a little bit more. It is starting to clump together, but it still mostly has sand properties. Okay, seems like we've got a pretty good texture going right now. As you can see, it when we move it, it holds its shape. So no longer just regular sand, we can mold it and form it into different shapes. Now we'll look at what is causing this to happen. Okay, so this is what is happening with our kinetic sand. So first of all, what is kinetic sand? It is regular sand that is coated with silicone oil. The key factors at play here are sand, which consists of 98% of it, and that's silicone dioxide, 2%, and then it's 2% dimethylsiloxane, PDMS for short. And part of that, I think that's the reason that the video had us add the liquid in slowly, is because it is supposed to be primarily sand. Here I have, this is a representation of the sand, silicone dioxide, and then this is the PDMS. And this is a polymer, which is a molecule made up of long chains of repeated units. And then this is a pretty good graphic down here that shows what is happening, and it's showing the polymer, that long chain of the repeated units that makes our kinetic sand possible. So the silicon dioxide molecules are larger, so they do create a slight polarity, and that helps to lead to hydrogen bonding. So when we squish the sand together, that's forcing more hydrogen bonds. When we pull it apart, that means the weight of those bigger silicon dioxide molecules overpowers the hydrogen bonds, and that's why it's able to break apart. Additionally, the lone electron pairs in the silicon dioxide create slightly negative electron density. Additionally, both molecules are very flexible, so that kind of contributes to the properties as well. All right, so properties of kinetic sand. What makes kinetic sand unique and special, different than regular sand, is the silicone oil. First of all, silicone is silicon plus oxygen. The cool thing about the kinetic sand is it can be a liquid that flows freely or a semi-solid that has rubber-like properties. So what we're dealing with is a semi-solid. The degree of the viscoelasticity depends on the length of the polymer chains in the silicone oil. So essentially, at long flow times or high temperature, it can become a viscous liquid, and then it's an elastic solid at short flow times or low temperature. So I'm guessing that if we were to heat up our kinetic sand, it would turn into a liquid. It moves slowly under pressure, but it does still move. So an example of that is if you were to use the kinetic sand to make a ball, it would hold that shape, but then over time it does move, so you would find kind of a flattened ball later. Other properties of kinetic sand: it's not too sticky, easy to clean up because it does only stick to itself. It's non-toxic and non-flammable, which I think is what makes it pretty popular toy. And then a fun fact, this was originally developed with the intention of cleaning up oil spills. Thank you for watching.